Number 26 out of Thomas's Calculus, section 5.4, and Fundamental Theorem of Calculus, and we have the definite integral from 0 to pi of 1/2 times the cosine of x plus the absolute value of the cosine of x dx. And whenever we have an absolute value, we're doing a definite integral, or even an indefinite integral, but in this case a definite integral, we need to be concerned where the function where we're taking the absolute value is equal to 0, or where it changes from positive to negative. And if that that value where the function is equal to 0 is not in the interval on which we're integrating over, then we can just drop the absolute value sign and multiply by a -1 or not, depending on if what we need to do to maintain the absolute value. But in this case, the cosine of x is equal to 0 at pi over 2, and it changes signs at pi over 2. So, and pi over 2 is in the interval from 0 to pi. So therefore, we're going to need to break this up into two integrals. And we break it up in the integral from 0 to pi over 2 times 1/2 times the cosine of x. And then the absolute value of the cosine of x, well, the cosine of x is positive from 0 to pi over 2, so we can just drop the absolute value signs, just the cosine of x. And then we're going to add it to the definite integral from pi over 2 to pi of 1/2 times the cosine of x. And then the cosine of x, the cosine sign is negative from pi over 2 to pi, so in order to drop that absolute value sign, I have to subtract the cosine of x. And when I do that, I actually get the cosine of x minus the cosine of x, which is just 0. And the definite integral from pi over 2 to pi of 0 is just 0. Because remember, we're taking the area under the curve, and the function 0 is the x-axis, and the area under that curve is just 0. So we'll just clean this part up a little bit because it becomes a little easier. So we have the definite integral from 0 to pi, and we have 1/2 times the cosine of x plus the cosine of x. Well, that's 2 cosines of x times 1/2, which is just the cosine of x dx. And now when we integrate, the function whose derivative is the cosine is the sine of x, and then we're going to evaluate from 0, I'm sorry, this is 0 to pi over 2, from 0 to pi over 2, so we have the sine of pi over 2 minus the sine of 0, which the sine of pi over 2 is 1, and the sine of 0 is 0. So our answer, and I went off the page, is 1.